you now get into your projects. I'm pretty sure it's been a while since we last met, so that means you've been working a lot on your own. So today I'll just be summarizing most of the concepts you covered in machine learning, and then cover what you'll be doing for your Capstone project. If time allows, we'll also do a small demo on Azure, how you can also train your models without writing a piece of code. I know we already covered the Azure ML, AutoML, and the ML Learning Designer, but then there's something else. So if we get time, we'll cover it. So I'll just go ahead and start with my presentation, hoping that you can all see what I'm presenting. And the first thing is we've been learning a lot, so we'll want to put into practice what we've been learning, of course. So I know you've probably gone through the courses. There's some bits where you had to practice on your own, but then, yeah, right now we really need to do an end-to-end project. You've done Python, understood what Python was. You went ahead and did a bit of data science, did a bit of cleaning, and then dived into machine learning. The data that you had cleaned, learned how you can be able to use it to make models. And finally, now you want to put all this together. So a recap is all these courses, all these resources that you used can be found in the links there. So if you need to like go back and polish on any of them, Python, data science, machine learning, you can do so in the resources, the links that are provided. And then I did a summary on like the 30 days of learning for data science specifically, and you can find the whole blog there. It has links to each session we held for each topic, as well as a summary of anything else you might need. I'll also be doing something similar for the machine learning part. So if you're also interested in machine learning after this session, probably tomorrow, you'll see a blog going up summarizing everything that we've covered. So before, I know we've not done so much sessions on machine learning. We did 3 main sessions in machine learning. So I'll go ahead and do a recap on each of the different aspects that you should have covered, and then finally go into what our project will be. So as I mentioned, the main thing is doing a recap of the machine learning part, you understanding machine learning, what it is, what it entails, and then going ahead and digging through the different machine learning models and algorithms. Okay, so let's start with first understanding the machine learning process. The first thing is when you're given data, you don't just go and dive into the data without having in mind what exactly you need to do with it. So the first thing is understanding why you need the data. So understanding the problem. So is it that customers are not buying things from this shop anymore, or like the sales are dipping when you need it to be rising? So something of that sort. So you understand what the problem is, and then go out to find your data. So the data can be readily available on platforms like Kaggle, or the business can provide it for you, or you'll have to go and scrape the data by yourself, probably from platforms like Twitter, or the other way is you going to collect the data in the field. So I'm pretty sure when you're doing your final research projects in school, you'll have to have data for the project. So this means you'll have to go to the field and collect some of the data that you might need. And then once you're done with having your data, the next thing is choosing a training method for your data, because you've understood what your data entails. So you want to now go ahead and train it. So training will be defined with what exactly do you want your data to give you. Is it predict something numeric? Is it classify data into different parts? So choosing which training method you want to use, then going ahead and training your model. Training isn't the end of everything. So once you train, you have to test to evaluate your model score, probably things like accuracy and mean squared error, trying to figure out whether the model performed as good as it should have. So if you get like an accuracy of 50% and it's a medical thing, So to predict whether someone has diabetes or not, and your model is giving you an accuracy of 50%, that means your model is underperforming very badly. So that's another thing you'll have to check. Going to the field, evaluate your model, then do a bit of now parameter tuning. Should you increase different parts of your model, or should you increase the different columns you're using to train your model or something of that sort. Once you're good that your model is actually tuned very well, that means the last step will be for you to go ahead and do the predictions or the purpose you build your model for. So is it building a recommender system at the end? Is it checking for sentiment analysis and so on? So some of the keywords you learned here probably is features and targets. So features are what you have and targets is what you want to predict. So probably you want to predict my height and you want to predict my height, or you want to predict whether I'm overweight or underweight. So the features you might have might be my weight, height, my eating habits, and so on, so that you can predict whether I'm overweight or underweight. So those are the features are the things that you use for the prediction. Then the target is what exactly you're predicting. And then the other thing is when you're training your model, you have to split your data set into 2 or 3 sets. So when you're splitting your model into 2 sets, something like training and testing, so you split it into like 80% of your data to use for training and then 20 for testing. What does this help in? So training is like what you're using to train your model in, and testing is what you're using to evaluate your model with. And then there's also something called a validation data set. So this one you just use to tuning your hyperparameters here, ensuring that everything is okay, the model is actually working perfectly. So that's it about the data science process. So the next thing is the machine learning and data science process. So the next thing is diving into now the different techniques and algorithms you went into. So the first one is regression. We had the session on regression by Bunmi, and you can watch the session here at aka.ms/30dl-regression. So that's the link to the session. And with regression, it's technically when you're trying to predict something like the height of someone or something of that sort. So predicting something that is of a numerical value, and you'll use a model such as linear regression algorithm to predict your values. And then also you might be interested in doing like a binary regression, so 1 or 2. So whether this email is spam or not spam. So this mainly falls under classification, but you might need to do something using a model called logistic regression. So yes, the name is logistic regression, but it's technically not used to give you numeric values, but just categorizing whether or not, like whether this person is vegan or not, or something of that sort. So after we covered regression, we went into how we can deploy our model. So in deploying our model, we had some keywords that probably you met for the first time, something like Flask and Pickle. But then we also covered why it is important to deploy your model. Why exactly do you need to create an app for your model to be used? And the main reason is because most of the time someone might want to use your data science, the model that you've trained in an application, and they may not know how to convert the model into now something that's consumable by the application. So as a data scientist, you might need to know this to be able to go ahead and share what you've been doing. So we used a Python framework called Flask, and Flask is just basically a templating engine that you can be able to use to build web pages. And then we also did something called pickling. So pickling your model is when you like flatten or serialize its structure to be able to use on the web. So the problem with having pickle is it's not very secure. So whenever someone shares with you the pickle file, ensure that file is from someone that you can actually trust. So after regression, you went ahead and did classification on your own. And classification is similar to regression. It just does the same, like the process of the code that you write is very similar to what you're writing in regression. The only difference is with classification, you're trying to group your features. So trying to group whether a flower is this type or not, trying to group whether someone sent an email that's spam or not. And here you can do either binary classification or multi-class. Binary is when you're just dividing into two, so 0 or 1, yes or no, something of that sort. Then multi-class is when you have various categories. So under classifiers, there's this image that I like, and it shows you the different should I call them models that you can be able to use. So it gives you like a guide. So this is where you start. You have 50 simples. What are you doing? Predicting a category. Is your data labeled? This means is it supervised? Okay. For more than 100K samples, this is where you're going. For less, this is where you're going. So these are the main classification models that you can use. The first one I can talk about is K-neighbors classifiers. K-neighbors gives you, it's also something that you'll use in clustering, and it gives you it creates different points whereby these different features look like they all align to this cluster. These other ones align here, these other ones align here. So it's just creating different central points to predict now data depending on where they are. And then we have support vector. So support vector machine is, support vector classifiers are under support vector machines. So this one gives you, it's like, gives you points in space to maximize the distance between two categories. So it just aligns different points, the farthest point this one can be and the rest. So it just gives you a mapping of the different categories. And then the other one we have is ensemble classifiers. These are like random forest and other boosts. So with random forest, it creates a forest of decision trees. So it's like how you're creating a tree. So this one, and then I don't know how best to explain it, but yeah, just creating a tree randomly. Like when you plant a forest, the tree has now like I think there's someone who's unmuted. Sorry for that. So yeah, so it gives you now the parameters, like the set number of trees per region in a regionalized forest. So an example of now how you can do this in code, I think you also realize that the code for machine learning is quite simple. So once you identify your Y and your X features, the next thing is splitting your data into now like X train, X test, Y train, Y test. And then the next, after you've split your data, you've identified which part of your data is the features, that's X, and which is your target, that's Y. This is the splitting, so that this means test will be 30%, and then 70% will be in training. Then the next thing is defining your model. So the model name is logistic regression. These are the different characteristics that it has. And then once you've defined your model, you now fit, meaning you now train and check whether it actually gives you the right thing. Once you fitted your model, you go ahead and now, for example, since this is a classifier, you go ahead and check something like the accuracy, which is very simple if you ask me. Like machine learning has a very
Sorry, we've lost Bethany. Guess it's our
Yeah, I'm
network.
back.
Okay, she's back now.
So I think I just got kicked out. I'm not sure why. So yeah, so I think you've understood like the simple, like how to write a simple Python code. So this code applies to most of the things that you'll have to write when you're training your model. So the first thing is just splitting it, defining what exactly the algorithm you're using, fitting the algorithm to the data, and then once you've been able to train it, now testing the score to evaluate it whether it's accurate or not. And then afterwards, depending on all the accuracy level, you'll have to do things like you'll have to go ahead and do some things in regards to hyperparameter tuning to ensure that your score is actually accurate. So yeah, that's it about the main classic types of supervised machine learning. So the other one is unsupervised, which is for unsupervised, we use something called clustering. So clustering is when you literally do not have like, let's say you have customers and you want to classify them. So in the market, you might not be able to like tell like this customer belongs to this category and so on. So that means you have to give it to a model that will actually make sense of the chaos. So with clustering, it just divides depending on like figuring out like what are the characteristics of these customers, how do they look like, what's the spending methods, okay, you can keep them here. So for example, you might find that sometimes you might receive an email or a message from your service provider telling you, hey, school is about to open, or are you ready for your exams? Prepare with this and this and this, something of that sort. Or you've just finished school, do you know what next? Something of that sort. You'll realize it comes in a period that you might have probably just graduated school or you're still in school. Another one is when you're being given offers, or yeah, when you're being given offers by your telco company. So you might realize today you're getting offers that are very cheap, and in a few months you're getting offers that are very expensive for you. So this means they saw that you can be able to actually afford the cheap ones. Now they're moving you to a new cluster or something of that sort. So that's about clustering. And the main method you checked out was K-means, which is also one of the easiest machine learning models. And perhaps you can ask yourself, how can I use these methods in real life? So as I've mentioned, customer segmentation, determining which type of customers are this. And then another one is for anomaly detection. So a bank can be able to like watch how you consume, how technically not how you consume, but how you use your data. And then when a transaction made probably at 3 a.m. at night, and that's not a time you normally make your transactions, they might catch that as a fraud. So that's also something else, anomaly detection. Yeah. So this session was live. You can watch it at ika.ms/30dl clustering. So you'll be able to get deep into now how do you like create these clusters? How do you know whether you need 3 or more clusters and so on? And then the other thing that you did, this one you did on your own, was time series. Time series forecasting is technically like going to the witch doctor and asking the witch doctor, okay, do you know whether I'll pass my exams or not? But now this is based on data, based on past performance, and pretty much more reliable. So as is said in the slide, it's like a crystal ball telling you how you'll do in future depending on how you did in the past. So things under this, under time series, is checking things like trends, how are things changing over a period of time, seasonality, is there different seasons where like buyers are more and then they're less, and then also checking things like outliers. Outliers are things that abnormal in a way. So looking at like the scale, if it's going this way, no, let's use something that's happening currently. When you're looking at the stocks and the cryptocurrency market, you can see it's right now it's dipping very much. So this is an outlier because most of the time you find that the graph is normally either going up, down, but then when it's dipping completely, you have to now check your money and see, okay, do I still have the ability to buy the dip, or can I just accept my fate and move on? So that's also something time series forecasting can help you with, checking like your stocks and so on. So there are different terminologies under time series. Time series itself is a terminology. So series comes, of course, from sequences. So time series is a sequence, like a sequence taken progressively over a period of time. And then there's also time series analysis. So this is now you analyzing the different series. So it can be, for example, analyzing things over months, analyzing things over a period of years, and so on. And then there's also time series forecasting. So forecasting is now when you're now predicting the future. And one of the models that we use in this is called ARIMA. ARIMA is autoregressive integrated moving average. And I'm pretty sure you went through this, did a bit digging on it, and you've been able to know like analyzing your time series using linear regression, and you can be able to now predict what the future might hold. And then the last thing that you worked with was natural language processing. So natural language processing is just you working with data. So no, you working with text data. So being able to predict whether the text data you're using is which language it is, translating different languages, also doing things like sentiment analysis, how do people feel about a certain thing. But then the main thing I'd want to talk about is probably the key terms you came across. So key terms like tokenization, embeddings, parsing, POS, parts of speech tagging, and so on. So what do these terms mean? So we can start with the first one, tokenization. Tokenization is when you, how can I say this? When you, when you grouping your sentence into words instead of splitting your sentence into words, instead of using the sentence as a whole. So for example, if someone says, I am angry, so separating the words, I am angry, to be able to evaluate. So for example, when you want to evaluate the whole sentence, things like I and am, if you're looking for sentiments, might not be very useful. But angry is very useful because it shows that this person has a negative emotion. So things like that. So tokenization is when you're just splitting your text into different tokens or words. And then the other thing with this is you also want to like remove things like punctuation marks, things like delimiters that probably when someone is speaking might not make sense. Then the other thing is embeddings. Embeddings is how you convert text data to numerical data. So it's done in such a way that you go back to clustering like the different words and clustering together, like which ones have the same meanings, which one do not, and so on. And then you're able to now understand like how these different words relate to each other. And then there's parsing and part of speech tagging. Of course, this is very simple because you're working with now a whole sentence determining this is a verb, this is a preposition, this is a noun, this is also a noun, and so on. So parts of speech tagging and parsing is just giving your text identity in terms of now the English language. And then there's one before the n-grams, there's one called the word and phrase frequencies. This is you now accounting how many times the different words appears or phrases appear in a sentence. So when you're doing word and phrase frequencies, it helps you now like determine, okay, once you've been able to do this, how often, like when you're creating a new sentence, if you want to like use natural language processing to create new words, so how do you determine which words come next? Then n-grams is weighing, now you weighing the letters, the words that you have. So with the n-gram score, it's you're trying to feel like, for example, if these words go together, what their weight is, and so on. So for like a specific word, it just goes with a unigram. Then when you have 2 words, bigram, and so on, 3 words, trigrams, and so on. So you just trying to determine what is the n-gram score. And then I've spoken about sentiment analysis. If you're new to this, sentiment analysis is just determining how people feel in a specific sentence. So how do you determine whether someone is mad, someone is happy, and so on. Then the last word is lemmatization. There are, of course, other things that you may be able to go and evaluate, but with lemmatization, it's you getting the stem of the word. So let's see, for example, this word is tokenization, but the main stem word of this is token. So I can remove, with lemmatization, I can remove the entirety of this and just remain with tokens. Another word that you can do is probably verbs. So there's work, working, worked, works. So that means the root, the stem of this is work. So if someone says working, works, worked, for our model, it will just look at it as worked. That's it about NLP. So the last part I'll want to do is probably just show some code on NLP. So this was a Twitter analysis. This was me extracting data from Twitter and trying to find the sentiment analysis. But then one of the things you can do is do something called a word cloud. So with a word cloud, you can be able to see like the different words and how often they appear in the sentences and so on. So for this, I had to combine all the tweets that I had extracted. So combining the tweets, then for each tweet, I took the value, split, and then got the tokens. So these are the words that now split into different tokens. And then previously, before this, probably it's something that you may not see. I had removed things called stop words. Oh yeah, so you can see this tweet non-stop, meaning I had removed stop words. Stop words are those words that may not necessarily mean anything when you put it in front of a computer. So things like I have, so you can remove I and have because they're not keywords that you want to visualize. So if someone says, hey, there's a job in Kenya looking for an aerospace engineer. So words like there is a job, I remove remain job, looking, I stay looking. For a job, looking for I remove one then remain with aerospace engineer. So remain with now the keyword. Yeah, that's it about NLP. So since we have, let me see how much time we have left. We have about 20 minutes left. So I can do a demo before we go to the Capstone project. I can do a computer vision demo with Azure. I've not talked about computer vision, and you haven't actually met it in the coursework. So I'll want to do it with Azure, meaning I won't be writing any code at the moment, but I'll just be taking you through how you can work with computer vision. So the first thing is I'll go to Azure, so portal.azure.com. I sign into my account. And then go back home and create a resource. So the resource I want to create is a custom vision resource. So custom vision. So you can, there are different ways you can create these resources. You can go home and probably create a resource directly from here, or create a resource from here. But to just save on time, I'll just do what I did, custom vision. And then there's the option, I already have like very many custom vision resources available. So this means I'll have to, and I want to do a new demo, so I'll just have to go ahead and create a new one. So create, oh, interesting. Yeah, so I want to be able to train and predict different objects, whether they are representative or what they do. And then the subscription I'll be using is that. Resource, I'll do 30 days of learning. That's the resource group I'll use. For the region, I'm in Kenya, so West Europe is my nearest. So this means I'm doing a training resource. So for training, I'll call it 30 days of learning. Yeah, 30 days of learning. The pricing. So pricing, normally go for the cheapest option. I'll go for the free version because this is mainly a demo that I'm doing. And then, sorry, I'll have to move my PC a bit to be able to see everything in a second. And then the other thing is you've determined now the pricing, and then the pricing for the training, then the pricing for the prediction. So I'll also go with free. And then is there anything else I'm missing? Nope, I'll just go ahead and create. Let's validate our resource, see if it works. Okay, so it's passed the validation. So I can just go ahead and create the resource. So as it loads, in case you have any question, you can go ahead and ask, but give me a minute as we wait for the deployment. Okay, deployment is still in progress. So once the deployment is done, we'll go to customvision.ai. Yep, our deployment is complete, and then we'll create a new project. So the project we'll be creating is I'll want us to determine whether the images is either a human being or a horse. So this is very simple. So probably our model will outdo itself, but let's see how it goes. So I'm done here. So as I'll come here and choose the resource that I'm using. And then we want to predict horse or human. So this project is to predict whether the image is of a horse or human being. And then, of course, we're doing a classification, trying to classify whether or not it's a dog or a horse or a human being. We'll only have a single tag, so it's an object is either a horse or a human being, and the domain is general. So that's it. Then we can create our project. So for the data set for this, I used Kaggle to get the data. So give me a second. look for the exact data set I used. So this is the data set I used to be able to get the data. So these are images free for use if you want to like use to experiment with them. You can go ahead, and it just gives various types of horses and various types of human beings. So we have like 15 images of 500 images of horses, 527 images of human beings. So once it's done, this is now the home page, and this platform you do not have to write any code. So it's very, very simple to use. So I've already downloaded my horse and human being images. So I'll just come and select. So horse or human, the training data set. The first one I'll do is horses. So maybe I can just check the top, I don't know, top 30 images, and then I'll give this image the name horse, and then upload the 30 files. So you can upload all of them, but I know if I decide to upload 500 images, my network will just tell me goodbye. So I've gotten 30 images of horses, so I'll do the same for humans. Our problem is this one is not randomized enough. So I can probably do this 3. Right, human, upload 18, and then look for male images. So that's done. And then I'll add images of probably male. Yep, so here's some male images I can use. Oh, 55, that's a lot. So I'll still tag them as human and upload the files. So once you've uploaded the files and tagged them, so I've given the tag, this is a human being, also given the tag, these are horses. So I'll go ahead and train my model. So you can do advanced training if you want this to be super perfect, but because of time, we'll just do a quick training, and it won't take long to train, but then after the training is done, it will give you now an option to test whether or not your models are good or not. And then afterwards, you'll have to see your predictions here. So let's see. Our training is continuing. So the other thing I want to show you is now how you can consume. We are currently training our models. So how can you consume this as an API? So I'll use Postman to give you the example. Postman, let me just go to Postman. I don't know the right, yeah, postman.com. I don't know the right URL. So with Postman, you can be able to test whether or not, like if you use your API, if you use this as an API in your project, whether or not it will work. So let's see, training is still continuing. So I'll come here, I don't want to create a team, go to workspaces. And then add a new, yeah, so we'll do a post request. And then on the headers is whereby we'll now add our key. So authorization here will be by an API key, and we'll add our prediction key here. So prediction key, and then we'll have to add the prediction key here. But then the other thing we can add in the header is now like what type of image we're expecting. And then in the body is now whereby we'll use raw data, JSON, and under JSON, we write like what exactly we want to check, whether it works or not. Okay, so let's get back to our model. It's still training. So let's give it a few more minutes as it trains. Or let me try and use the one I had previously made. So customvision.ai. And then I'll go to the previous project since this is taking a long while training. So horse versus human. And then once you've trained the performance, you can see it performed very well because I had like 500 images. And then I'll go ahead and the first thing you'll see is this publish wouldn't be checked. So I'll go ahead and publish my model and then probably give it a name. So human or horse, and then the prediction resource. I'll choose the prediction resource we just created, go ahead and publish. And under the prediction URL, you will be able to get all the things that you might need. So probably before we go back to Postman, we can also do a quick test to check whether our model actually worked. So I'll Google human beings, as well as I'll also Google horse. So under human beings, I'll come to images and probably copy the URL to this. Copy image link. Then in custom vision, I'll add the URL here. I'm not sure if it will work, so let's see. Oh yeah, it works. So it's giving me a 99% probability that it's human. If I do the same for horse, so this is a horse, and then come to images and do the same thing. So probably, let me use this one. Copy image link. Then I paste the link here. Invalid image source. So I'm sure it will give me the results that we want. So we can do. Okay, also this the URL is incorrect. Let's try this one, copy image link. Oh, the other option is you can just go ahead and download the image. If it refuses again, yeah, this one works. So yeah, it's giving me a 99% probability that it's a horse. The other thing you can do is probably just download the images. So I'll go ahead, download the image, save, and here, browse local files. Go to my downloads, download the image, test, and you can see it still gives me the same results. So if you're doing this as an API, so if you want to use this in your application, let's also check if it will work. So this is now like the prediction URL. So we're doing a post to the request URL, it's that one. And then also the prediction key. This is now our API key. To be very careful, you shouldn't share your API key in public. So I'm doing this because it's a demo that I'll delete afterwards. So we said the under authorization will be using an API key and we'll be adding it to the headers. But then it's also telling us we have to set the content type in the header as application/JSON. So we'll also come back to header and do the content type and set it to application/JSON. And then in the body is now whereby we add a link to the image you want to predict. So this is the code that we'll use. And then probably need to get an image to do this. So we'll go back and look for images of horses again. Images, I think I'll just copy the first one. Copy image link. And then under here, paste the link and send the request. Let's see if it will give us an answer. So yeah, so it's giving us a probability that it's a horse, or a probability of 99% that it's a horse, and a probability of 0.02. I don't know how many zeros because it's -5. 27 that it's probably a human being. So that means the higher probability is it's a horse. So that's how you now work with Azure and computer vision to do Azure and custom vision to do a computer vision problem, and you can see it works. So if you want to add this to your application, you'll get all the rules here. So this is now the link that you'll request to. This is your authorization key. Then this is the type of content that you'll have. And lastly, the URL to pass through. So I think I've covered all I wanted to cover today. And with less than 10 minutes left, I think it's wise for me to go ahead and show you what the Capstone project will be. So our Capstone project will be building a recommender system. So a recommender system based on Netflix or any other streaming platform. And you might be wondering, okay, where are we getting the data? So this is the link to get the data. And if I go to this link, where are they gone to? If I go to that link, let me see. ek.ms/. Okay, let me go back to my presentation. Hoping it opens. Nope. So I'll have to just copy paste the link. So ak.ms/30 days of learning -Netflix. So if I go to the link, you'll see it's a data set that contains over 5,000 titles for Netflix, and it contains various information like what the ID is, what's the name of the show, what's the show type, who's part of the cast, and so on. So this gives you various information you might need to create a recommender system. So based on like now the different things such as gender, the description of the messages, probably who's one of the stars in the shows, you can now do a recommender system. So that's what I'll be asking you to do. So in case you don't like Netflix or you don't relate to Netflix, the other streaming data sets here. So you can go ahead and do something like HBO Max or Amazon Prime or Disney Plus or Hulu, Paramount. I have no idea what the rest are, but then you can go ahead and do any of the other streaming data sets. But at the end of the day, you have to create a recommender system for this. So you might be wondering, this is something you've not covered before, but the resources here for you. So under the resources that I shared, ak.ms/ML for beginners, we have an entire topic on recommender systems. So that's where you'll get your resources. So this project, you'll be able to do it for the whole week. So you can start with like this week, just looking at today, just looking at the data, go to Kaggle, figure out how you can figure out first which streaming service you want to cover, then figure out what the data set contains. So this is like the entirety of the data. So what does what does the data set contain? How can it help you? How might you want it to help you? Then do a bit of visualization and analyze your data. Do a bit of analyzation and cleaning and visualizing your data. Afterwards, you can go ahead, create a machine learning algorithm or model to help you now determine, okay, this is how we're recommending person A, person B, person C, and then create an application or now find a way that I can be able to, or Ola can be able to now come to your application and use it to determine what the different movies can be recommended to them. So in case you need like help or something of that sort, you can go ahead and look at what other people have done before. Kindly do not copy the code, just use it for your own analysis and look at what other people have done, for example, in terms of visualization, in terms of now like how they built the system, which applications they use to build the systems, and so on. But then that's now the entire project, creating a recommender system. I'll be putting up a blog tomorrow on more on this, on like anything else you may need to create. But then by Friday, we need to see your work. So by Friday, you can share with us what you've come up with. I'll be sending out a form. So you just share either your GitHub link, you have to share your GitHub link. And then if you have like a live place where we can see the project, you can also share that. If you want to use Azure, feel free to use Azure. It's not a must for you to write code when you're doing this, but I'll prefer for you to first go through the different processes like mentioned, cleaning your data, analyzing, visualizing your data, and then trying to figure out which machine learning platform you can use. And then you can go to Azure and see if there's a simpler way to do it. But yeah, that's it from myself. So thank you so much for joining today's call. Thank you for listening in. If you have any question, probably now is the time to ask before I end the call. So anyone with any question or any question I might have missed. Okay, so with no question means I think everyone has understood the project that you'll be doing. Let me put it back up. Let me even just take a screenshot and then I'll share with everyone. I'll share with everyone on Discord first before the blog is up. So yeah. Anyone with any questions?
From my end, no.
Okay, so I believe in the next few days, by Friday, I should be seeing projects being submitted. So thank you so much for joining in. It's always nice see the faces, technically not the faces, but the names behind everyone who's part of the program. So I'll upload this video in case you want to watch it again and share the link tonight. But from me, thank you so much for joining in, and I'll see you at the end of the week, taking stock and checking whether you've done the project. So thank you so much.